Well, here we are at the end of Chapter 4 in Unit 2. We're at Exercise 4-2. These are the application problems, or the way we're going to run into having to use these skills when we're in the kitchen. So let's start answering these questions. We have our very familiar dressing the chicken question. A chicken weighed 4.5 pounds when purchased and 3 pounds 2 ounces when dressed. What is the weight loss? Now that we can convert between pounds and kilograms and fractions and decimals, we will convert these weights to their decimal equivalents, an important skill. So if we take 4.5, it equals 4.5 pounds, because 1/2 is 1 divided by 2. That equals decimal 5. We get 4.5 pounds, or 4 decimal 5. 3 pounds 2 ounces. Well, that's 3.125 pounds, because 2 ounces is 2 ounces out of 16 ounces, or 2 divided by 16, and that equals decimal 125. So you put that together and you get 3 decimal 125. So let's take the decimals, 4.5, the 4.5 pounds. Let's subtract 3.125, the 3 pounds 2 ounces, and that gives us 1.375 pounds. If we needed to convert that decimal equivalent of pounds to ounces, we would take the decimal 375 and multiply it by the relationship between ounces and pound, which is, of course, 16. So decimal 375 times 16 equals 6. So the weight loss on this particular chicken is 1 pound 6 ounces. Now, if a restaurant paid a total of $27.94 for a roast of pork, and the cost was $1.49 per pound, how much roast did we buy in pounds and ounces? So your inventory came in, there's a big hunk of pork there, you realize the total price is $27.94, and the only other information you have is you paid $1.49 per pound. How much should it weigh in pounds and ounces? A little bit of logic and a lot of relationships, we're going to get there. So if we take the $27.94 and divide it by the amount we paid per pound, we're unit costing what we paid for pound by how much we paid in total. And you'll see that we get 18.751677 pounds. If we take that decimal equivalent of pounds, decimal 751677, and multiply it by the amount of ounces in a pound, the relationship, you see that we get 12.026832 ounces. If we round out that amount of ounces to the nearest ounce, we get 12 ounces. So the final answer to this particular question is we bought 12 or 18 pounds and 12 ounces. A baker needed 1 pound and 2 ounces of flour for cookies, 2.5 pounds of flour for a cake, and 1.25 pounds of flour for pastry. Let's find the total amount of flour the baker required, and we're going to give our answer in pounds and ounces. So again, the first thing we're going to do is convert everything to its decimal equivalent. It's just much easier to calculate. So I'm going to take 1 pound and 2 ounces, and I end up with 1.125 pounds. 2 ounces divided by 16 ounces, the amount of ounces in a pound. 2 divided by 16, decimal 125. So I have 1 decimal 125 pounds for the cookies. 2.5 pounds, my goodness, I hope we know that's 2.5 by now. But again, 1/2 is 1 divided by 2 equals decimal 5. So 2.5 pounds, or 2.5 pounds of flour for the cake. And then we take the 1.25 pounds, and again, I hope we know 1.25 or a quarter is decimal 25. But if we're still not sure, let's get those calculators out and do 1 divided by 4. We get decimal 5. So 1.25 pounds, or 1 decimal 25 pounds, is what we need to do the pastry. So now all we have to do is add the 3 decimal numbers together, and we just get the calculator. 1 decimal 125 plus 2 decimal 5 plus 1 decimal 25 equals 4 decimal 875 pounds. Great stuff, but we need it in pounds and ounces. We still have a no-brainer part. If we have 4 whole pounds in the decimal equivalent, we're going to have 4 whole pounds with the pounds and ounces. But what we're going to do is take the decimal 875 pounds and multiply it by the amount of ounces in a pound, which is 16. So decimal 875 times 16 is 14. So we get a final answer of 4 pounds and 14 ounces. That's how much flour is needed. Let's take a look at the cost of butter. If we paid $4.77 per pound, let's calculate the cost for 25 kilograms. So we're going to need to know the relationship between pounds and kilograms. I'm going to right off take what I paid per pound and multiply that by the amount of pounds per kilogram. 2.2 pounds is equal to a kilogram. So if I multiply the unit price by the amount of units it represents, in this case 2.2 pounds will represent a kilogram, I realize that the cost is $10.494 per kilogram. I then simply take the price per kilogram and multiply it by the 25 kilograms that I'm looking for, and you can see we get a cost of $262.35 for 25 kilograms. Of course, there's another way of doing it. I'm going to take the amount of kilograms that I'm looking for, and I'm going to convert that into the amount of pounds 25 kilograms equals. And since that relationship is there are 2.2 pounds per kilogram, I'm going to multiply the 25 kilograms by 2.2 and find that I want the cost of 55 pounds. Now it's easy. I take the 55 pounds I'm looking for, I multiply it by the price per pound, $4.77, and you realize I end up with the exact same number, $262.35. So depending on the relationship you use, there are more than one way of doing most of the stuff that we're doing here. Let's go on to the next one. Ground allspice sells for $12.40 per kilogram. We want to know the cost of 1 pound, rounding off to the nearest cent. So I'm going to take the cost per kilogram and divide it by the amount of pounds there is in a kilogram, and that will give me the cost of 1 pound, which in this case rounded to the nearest cent is $5.64 per pound. Now I go to another one, tomatoes. We've got them priced at 79 cents per pound, but your recipe calls for 3.5 kilograms of tomatoes. We need to calculate that cost, and we need to round the final answer to the nearest cent. So I'm going to take 79 cents per pound, multiply that price per pound by the amount of pounds in a kilogram, 2.2. So 79 cents times 2.2 equals $1.738 per kilogram. There's my cost per kilogram. I'm going to take the cost per kilogram and multiply that by the amount of kilograms my recipe calls for, 3.5. And I find that my answer is 6.083, but I need to round that off to the nearest cent. So I get $6.08 for 3.5 kilograms of tomatoes. Oh, look, there's another way of doing it. I'm going to take the 3.5 kilograms my recipe calls for, and I'm going to calculate how many pounds that equals by multiplying the 3.5 kilograms by 2.2 pounds in a kilogram, and I realize my recipe is looking for 7.7 pounds. I then simply take the amount of pounds I need, 7.7, and multiply it by the cost per pound, 79 cents, and I'm getting to the same place. $6.083 rounded to the nearest cent, I get $6.08. Next question, our wonderful milk question. Milk sells for $4.39 for 4 liters, but we only need 6 ounces for our recipe. We need to calculate how much 6 ounces is going to cost us, and we're going to round off the final answer to the nearest cent. So we have a bunch of different ways we can go here. Let's tackle it this way. I like the smallest units possible, so I'm going to figure out what 1 milliliter costs. If I paid $4.39 for 4 liters, that means I paid $4.39 for 4,000 milliliters. If I divide what I paid by the amount of units I got for that price, I see that my cost is very small for 1 milliliter, but that's okay. I'm going to use that to do more calculations. Now that I know the cost for 1 milliliter, I need to remember my relationship between milliliters and ounces, and that of course is 28.4. So I multiply the cost of 1 milliliter by 28.4 milliliters, and that will result in giving me the cost for 1 ounce. Once I have the unit cost for 1 ounce, I multiply it by the 6 ounces my recipe is looking for, and I realize I get this unrounded number. And when I round it off to the nearest cent, I see that, oh my goodness, 6 ounces of milk is costing me 19 cents. Now, let's take a look at the cake. We're trying to make a cake, and it calls for a 9-inch by 13-inch pan, but all of our pans are in metric. So we need to calculate the size of this cake pan into its metric equivalent, in this case centimeters, so we know what size pan to use to get the cake done. So the relationship between inches and centimeters, don't forget 2.54 centimeters equals 1 inch. So let's multiply 9 inches by 2.54, and then we're going to multiply 13 inches by 2.54. Again, 2.54 centimeters equals 1 inch. So we get 22.86 centimeters by 33.02 centimeters. We want these two numbers rounded off to the nearest centimeters. So we see that we're going to need a pan that is 23 centimeters by 33 centimeters.